So for question 6, same situation. Let's imagine that we have sine of q is 1 over root 2 again. We've been here before. Q is going to be pi over 4 plus 2 pi n, or q is going to be 3 pi over 4 plus 2 pi n. I'm going to put this down a little bit further. Or q is going to be 3 pi over 4 plus 2 pi n, except we don't have a q. We have theta over 2. So what I'm going to do in each case is get rid of the 2 on the bottom by multiplying by 2. So theta then is going to be 2 pi over 4, so pi over 2 plus 4 pi times n, and down here theta is going to be 3 pi over 2 plus 4 pi n. So that, let's look at what this looks like on the graph. So once again, we can say our period is 2 pi divided by 1/2, which gives us 4 pi. So each step, I know, is going to be pi. And let's see what this looks like. So we have pi, we have 2 pi, we have 3, 4, 5 pi, 6 pi, 7 pi. Let's go back a pi. Okay. And it's still sine. So we go through the regular routine, and we're looking for where this is equal to 1 over square root of 2, which is about 0.707. And this point, the only way I'm going to get this is by doing exactly what I had done before. So I'm going to say that this is pi over 2. If I want to use the symmetry, I know that this distance is going to be equal to this distance. So in order to find my coordinate over here, I'm going to take the pi over 2 distance and subtract from 2 pi. So that's going to give me theta is 3 pi over 2. In order to get the other terms, well, I know the period is 4 pi, so I'm going to have pi over 2 plus 4 pi m, and this one as well, I'm going to have to add a period, 3 pi over 2 plus 4 pi n. And in this case, if I'm looking for the solutions over 0 to 2 pi, well, I can see I still have 2, and that's going to be just pi over 2 and 3 pi over 2, which makes sense in terms of these, because certainly if we add 4 pi, we're going to be out of our 0 to 2 pi range.